So this information video will look at chronic responses to training. So what we're going to do is there's a video from Activate Ed that pretty much does this. It's just a bit different format, so it's really good. A different voice. So hopefully we'll play that. It's about 9 minutes, and then I'll look at a couple of case examples after, and then you have the preparation for the chronic response test and the review for the chronic response test. So there's lots of resources around this stuff, so we can tune in and use all those. So first we'll look at this video, then a couple of case examples, and then you'll have lots of chance to revise this section.
Hi, welcome back again. This is Jason Wood from Activate Ed. By now you've probably finished your training program, and so it's time to start thinking about the chronic adaptations that might have or should have occurred as a result of the training that you've undertaken. So let's have a look at the chronic adaptations to training. So the purpose of training is to improve performance, and chronic adaptations are things that occur or changes that occur as a result of long-term involvement in training. The term chronic is often associated with something that's negative, but really what it means is something that's associated with long-term use. Changes are physiological and are the result of the physical demands placed on the body, and they're specific to the type of training being undertaken. So they're aerobic or they're anaerobic. And the changes are also specific to various body systems, i.e. the cardiovascular, respiratory and muscular systems. So let's look at each one of these in isolation. Let's start looking at chronic aerobic adaptations of the cardiovascular system. So some of the things that we'd expect to happen are an increase in the size of the left ventricle, which therefore results in an increase in stroke volume. That's more blood leaving the heart or leaving the left ventricle every time the heart beats, and an increase in cardiac output. So that's the amount of blood leaving the heart each beat. And they all result in larger volumes of blood leaving the heart. And that's really critical because the blood delivers oxygen and nutrients to working muscles. We also get things like increased blood volume, increased plasma levels, increased red blood cell count, and increased hemoglobin, which are really important because they carry oxygen in the bloodstream. So all of those things result in an increased oxygen carrying capacity of blood. So now you combine an increased ability to carry blood and a larger amount of blood leaving the heart, and we've got a lot more oxygen and nutrients being delivered to working muscles. We also get increased redirection of blood flow to working muscles, so we can get more blood to the places that we need it. Increased capillary density at working muscles, so that means that there's more blood vessels, more surface area for oxygen and nutrients to diffuse across into the muscle cells. And increased cardiac capillary density, so that means more capillaries that are feeding blood back to the tissues of the heart, because it needs oxygen to work in order to create ATP so that it can continue to beat. They all result in larger volumes of blood being delivered to where we need it most. We also get decreased resting and submax heart rate, decreased steady state heart rate, and decreased recovery heart rate, and that's due to efficiency. So they result from the ability to create the same amount of ATP with a lower delivery of blood due to increased oxygen carrying capacity and a more efficient aerobic energy system. We get increased high density lipoproteins and decreased low density lipoproteins, and they result in much clearer arteries with less obstructions, and that improves blood flow, oxygen delivery and nutrient delivery to working muscles. We'll skip this short video and we'll move on to the respiratory system. So we get increased lung capacity, which is a really broad term, so I prefer to talk about things like increased tidal volume and increased ventilation at max intensity. Tidal volume is the amount of air that goes in and out of the lungs every time we breathe, and ventilation is the amount of air that enters and leaves the lungs every minute. So by increasing those, that means that we've got more oxygen entering the alveoli, which is the site of gaseous exchange. We have increased alveoli capillary surface area, and we get increased gaseous exchange. So we've got a higher amount of oxygen in the alveoli to start with because of that increased tidal volume. That means there's a greater concentration difference between what's in the alveoli and what's in the capillaries, so more oxygen diffuses across into the bloodstream, so it then can be transported to where we need it. We get a decrease in the oxygen cost to the ventilatory muscles. So that's the diaphragm and the intercostals. That means less oxygen is required by those muscles in the process of breathing, and more can be distributed to working muscles. We get decreased ventilation at rest and submax, and that's because we've got an increased tidal volume that allows the same or more oxygen to enter the lungs with a lower respiratory rate. If we look at the muscular system, the changes here actually are associated more with the ability to use oxygen. So we get an increase in myoglobin stores, and myoglobin is similar to hemoglobin in that it carries oxygen, but it does this inside the muscle cell. So it attracts oxygen out of the bloodstream, which attaches to myoglobin, and then the myoglobin transports it to the mitochondria. And the mitochondria is the aerobic ATP factory, if you like, of the muscle cell. And we also get more of them, and they're larger. So we've got larger and more numerous ATP factories. We also have more oxidative enzyme stores, and that allows us to utilise oxygen in the breakdown of carbohydrate and fats, for that matter, to produce ATP. So that results in more oxygen being taken up and utilised by the muscle, and also results in an increase in AVO2 difference. We get increased glycogen stores and increased triglyceride stores, and that means we've got more fuel available for aerobic ATP production, and it results in an increase in slow twitch muscle fibre size. Training methods that we would use for this include fartlek training or continuous training, fartlek training, long interval training, and circuit training. So if you had an exam question that asked about, had those kind of training methods in a program, and it asked you the likely chronic adaptations, the ones we just talked about would be the ones. Let's have a look at the anaerobic adaptations, and these are quite different. So these are adaptations resulting from anaerobic training. So again, the cardiovascular system, we get an increased thickness of the ventricle wall, which is a muscular wall. And because we've got that increased thickness, a more powerful contraction can occur, and it results in a small increase in stroke volume. There's not the same size increase here because the size of the chamber hasn't changed. It's just the force of the contraction is a little bit higher. We get a little bit of increased cardiac vascularization, so a little bit more oxygen being delivered back to the tissues of the heart. And we get decreased blood pressure at rest and submax intensity. We skip to the respiratory system here, and we find that there actually are no measurable impacts on the respiratory system. So anaerobic training will see little or no change in the respiratory system. The major changes occur here in the muscular system. So we get a lot more stores, a lot more CP, a lot more ATP, more glycogen, and we also get more glycolytic enzymes. So that means there's more fuel available for anaerobic energy production, and we've also got more enzymes that allow us to break down that fuel, which means we can work at higher intensity for a little bit longer. We get more contractile proteins, a bigger fibre size, more motor unit recruitment, which is critical because really the all or nothing principle tells us that the only way we can make a more powerful contraction is by recruiting more motor units. We get increased speed of contraction, increased force of contraction, and we get increased size and strength of connective tissue. And that's really critical because if the muscles get bigger, they can create more force. But if we can't transfer that force to the skeleton through a nice strong tendon, then it's not much use to us. So they result in increased force production and higher intensities of work. We get increased lactate and hydrogen ion tolerance, so we're more resistant to that fatigue. We actually produce less lactate and hydrogen ions because we can rely more on CP, so anaerobic glycolysis becomes predominant later in the activity, which means we've got less reliance on anaerobic glycolysis. That means we've got less recovery time, and that's decreased, results in decreased effects of fatigue and improved ability to train more often. So training methods used for anaerobic improvement include resistance training, short interval training, medium interval training, plyometrics, and it could involve circuit training. So if you saw a training program that had those kinds of activities in it, it would be fair to assume that the chronic adaptations are likely to be anaerobic ones and therefore mainly muscular in nature. So I hope that's been really useful. Stay tuned, we'll have some more podcasts between now and the end of the year. Check out activateedvce.com We've got masterclass.
So that video, again, that Prezi that was presented through Active Ed Company, again, really, really good. So I was thinking about doing some case studies, but realistically, you have the preparation for your chronic response test online, you have the review for that chronic response test online, you'll have questions and things like that. So I'm not going to overload you with things that are outside the terminology used there. So I want you to make sure you're utilising those test resources. So maybe go there, have a listen, have a look at how things are worded. Now that you have some more idea of the terminology, you can go revisit them, then do some questions, then go back to them. All right. So good luck with your revision. You've got the resources there, so utilise them, and I know you'll do well.